Hi guys, so this is lesson 1.2 on operations with functions and composition of functions. If you're watching this in live time, if you're math 3, second period, you're watching this because I am not there at school today. So please make sure you're using your time wisely to get your notes done and save any questions for Friday. Like if there's a problem you really don't get, then I can go over it in person on Friday. If you're watching this because you're playing makeup, you were absent or something, make sure that you talk to me also if you have any questions. So first we're going to talk about operations with functions. So we've talked about what functions are in the last lesson and evaluating those functions at a specific input value of x. Now we're going to talk about what happens if we want to add functions together, subtract, multiply, divide, and also put functions inside of functions. It's kind of weird. But let's first talk about operations with functions. So you can add, subtract, multiply, and divide functions, believe it or not. So if f of x is 3x minus 7 and g of x is 13 minus 2x, find f of x plus g of x. You're adding these two functions together. So essentially you have a big plus sign right here happening in between those two functions. And I'm going to show that with the next, with what's under here. So literally I wrote f of x down plus sign g of x down. Just f of x plus g of x because that's what this is asking me. From here, you're going to combine any like terms that you see. Reminder that like terms need to look alike, meaning constant is a number without a variable on it. A constant here would be -7 and 13. Constants get combined because they're like terms, and things with variables that look alike, so this is 3x to the first power and 2x, -2x to the first power. They have the same exponents as well. Variables that look alike can get combined as well. So we're going to do the math. 3x plus -2x is 1x, and -7 plus 13 is 6. So we just end up with x, because 3x minus 2x is x, -7 plus 13 is 6. So you end up with x plus 6. Okay? And that's just combining like terms with addition. Reminder that I pre-write my notes and I have these little covers. So if you need to pause, rewind, slow the video down, feel free. So this new function right here is denoted as f plus g of x. So we put the f and g together with the plus sign or the minus sign or the multiplication or the division. And then we put x over here. So f plus g of x can also be separated as such, as we saw up here, f of x plus g of x, or we can merge the two together in parentheses. So what do you think these look like? Okay, if it's subtraction, we can say f of x minus g of x, separate. If it's multiplication, we can say f of x times g of x, separated. Keep in mind that if they decided to write it like g of x, let's do it, g plus r of x, then this means g goes first, g of x plus r of x. Same thing if there's a subtraction sign in here, g of x would go first. So it does matter the order that's inside here of the parentheses as well. Okay, just want you to keep that in mind. If the g and the f, or g in any letter, or f in any letter flipped, then you would just want to make sure that you're writing it in the correct order. Now, division is the only thing. Notice there's a little asterisk here that we have to make an additional note of. We're still going to put f of x over g of x like this. However, what can we never ever have in the bottom of a fraction? What can we never ever divide by? Hopefully you said 0. We can never divide by 0. So we have to put a little stipulation that g of x cannot equal 0 here. Okay? Only in division, g of x cannot equal 0. Anytime you have a variable in the bottom of a fraction, you need to indicate that it cannot equal 0. So for example, if I had x plus 1, and I apologize for my horrible handwriting that happens on here because it's really difficult, over 2x, then you would need to make the stipulation that x cannot equal 0, because if x equals 0, then I'm going to make the bottom 0. If I had x plus 1 over x minus 5. What's going to make the bottom 0? It's not 0 anymore because if I put a 0 here, that's negative 5. But what makes the bottom 0? What makes this bottom part equal 0? Hopefully you realize that a positive 5 would make the bottom equal 0 because 5 minus 5 is 0. So you would need to say x cannot be 0. And we'll see this in a couple examples in a little bit. Okay? All right. Hopefully you're doing okay with me. So we have directions here. We're given f of x equals x squared minus 8x plus 4, g of x equals 4x minus 3, and h of x equals x plus 2. Just like yesterday in 1.1, we want to make sure that we're using the correct function based on what letter they're telling us to use. It says find each function and indicate any restrictions in the domain. The only time you're going to have to restrict the domain is during that division piece or any time that you have a fraction with x on the bottom. That's where you're going to have that domain restriction. Okay? So f plus g of x. So I'm going to pop this f1 down here first, and then I'm going to pop the g1 down here with a big plus sign in the middle. I'm keeping parentheses around it so that you guys see that I'm writing the f piece, plus sign, and then the g piece. Okay? No big deal. That's all I'm doing. So again, for timing, now would be a good time to pause the video, record that down, play the video, and continue. After you do that, you are then going to combine any like terms. Okay, like terms look alike. X squared is the only x squared. There's no x squared over here. So that guy is just going to come down. Then we have negative 8x and a plus 4x. So think about what that math is. Then we have a plus 4 plus a negative 3. So I just wanted to do colors for you to kind of see that visually what pieces are getting combined together. So x squared comes down, negative 8x plus 4x becomes negative 4x, and then 4 plus negative 3 becomes a positive 1. From here, just look at it. I cannot combine anything else because an x squared does not get combined with a 4x, and you're done. Now, do you have any domain restrictions? I do not because I don't have any x in the denominator, so my domain is still all real numbers. Okay? All right. Rewatch that if you need to. F minus h of x, number 2. So I'm recording f down again, in parentheses, a subtraction sign, and then h of x in parentheses, just like this. So record that down. Pause the video if you need to. With subtraction, everything in the second piece gets the subtraction sign. So essentially what you need to do is distribute that subtraction sign to everything inside the parentheses, just in the second part. So I'm going to distribute that and say minus x, and I'm going to distribute that and say minus 2. Now I did not write this, but you are welcome to write a line down here that says minus x minus 2. I would actually encourage that. So, because I made these note keys a while ago, I would write this line if I were you. X squared minus 8x plus 4. Again, I apologize for my handwriting on the pen. Minus x minus 2, because both pieces get the minus sign in the second h of x part. So line 1, line 2 I've written in red, and then I'm going to move the yellow box for line 3. From here, just like before, you're looking for any like terms to combine. So again, x squared is the only x squared piece. Negative 8x minus 1x minus a single x. Think about what that is. Plus 4 minus 2. Think about what that is. Okay? So hopefully you have that. And line 3 would be the combining. So my x squared, negative 8x minus 1x is negative 9x. 4 minus 2 is a positive 2. Again, no domain restriction because you do not have anything in the denominator, any x in the denominator. Okay, doing okay, hopefully. Can't ask you. All right, number 3. So we have h times g. So again, I'm just writing the h first, times, you can put a little dot here if you want, but 2 sets of parentheses like this means to multiply, times 4x minus 3. Hopefully you learned this in math too, but I understand if you didn't. So I'm going to walk us through this just this one time, but we are going to revisit multiplying these a lot throughout this math class. So you will visit this again and again. There's two ways that primarily it's taught. Number one is FOIL, if you remember hearing that, and number two is the box method. Most students tend to prefer the box method, but I'm going to show you both. So the box method is a 2 by 2 box, since this is a 2 by 2 function. So I have x plus 2 on top and a 4x minus 3 on the bottom. Hopefully this starts triggering some maybe uncomfortable memories, but triggers some memories for you guys. I'm going to make my box a little bigger and I'm going to redo this. Give me 1 second. All right, apologize for my really crummy handwriting. That is a 4x and minus 3. So anyway, what you're doing here is you're multiplying each of these pieces across and down, and you're going to figure out what the new numbers are. So 4x times an x gives you a 4x squared. This goes along with exponent rules. We have x to the first times x to the first, so you get a 4x squared. 4x times 2 gives me an 8x. Negative 3 times x gets me a negative 3x. And negative 3 times 2 gets me a negative 6. And I did it all in a different color because the ones that are in the same color are the only two that we are going to combine, that negative 8x and that 8x and negative 3x. So these are going to be combined because they are my only like terms. Everything else you just write everything else. The other way that we do this is foiling. So we do our first set of numbers, which would be my 4x squared. O means outer set, so I would do my outer set of numbers, which would be negative 3x. Then my inner set, which would be 8x. And then my last numbers, 2 times negative 3, which is my negative 6. So that is foiling, okay? But either way that you do it, you are just distributing all of the numbers to all of the other numbers. So again, 4x squared, there's my negative 3x, my 8x, my minus 6, and then combine these two middle like terms, which gets me a 5x, and I can't go any further. And if I combine on my diagonal here, I would get that 5x. So I get 4x squared plus 5x minus 6, can't go any further, can't combine anymore, don't have any x on the bottom of a fraction, so my domain is all real numbers. All right, and then number 4 is division, f on top, h on the bottom of x. This is pretty easy because you're just going to write the f part over the h part. Later, I believe in unit 4, we are going to break this down and see if there's any factors in common that we would cancel, but for now, we're stopping here. There is no factors that we can cancel. This is where that domain restriction comes into play, okay? What is going to just make the bottom equal 0? What's going to make the bottom equal 0? That was supposed to be an arrow and that was terrible. So what you could do is set x plus 2 equal to 0 and solve it. How would I solve this for x? Well, I would need to minus 2 and minus 2. So therefore a negative 2 would make the bottom 0. Therefore x can't be negative 2. So that's where your domain restriction comes in. Domain is x cannot equal negative 2. Okay? And that is the gist of all of addition, subtraction, multiplication, and division of functions. So we're going to keep going with some more practice. Number 5 is another division one. We're putting h on top, g on the bottom. You're just going to write h on top and g on the bottom. That's all I did. And I can't I can't cancel anything because there's no factors that are the same. But what I am going to do is set this bottom again equal to 0 and solve it. This one has a little bit more steps to it, just 2-step equation though. I need to first get rid of this constant by doing the inverse operation, which would be to add 3, and I would add 3 to 0. It would make this go away. That would give me, I'm going to write it up here for you, a 4x equals 3. Some of us can see this very easily, like what the answer is going to be just by looking at this piece. Some of us cannot see it very easily. So if you cannot, I would suggest just over to the side of your paper, write 4x minus 3 equals 0 and figure it out by solving. I'm going to lastly divide by 4 because inverse multiplication is to divide. So x cannot be 3/4. And if you were to plug that in, you would get a 3 minus 3, which would be 0. All right, last one is a bit of a doozy. F times g of x. We have f, which is my 3-term polynomial here, times g, which is my 2-term polynomial here. If you're doing the box method, which a lot of students do, and I would recommend it, especially for these bigger ones, you are going to do a 3x2 box. For time reason, I'm not going to demonstrate all of the pieces out to you, but I would pause the video, give it a shot, use a pencil in case you make a mistake. You would do a 3x2 box. On top here, we would do an x squared minus 8x plus 4. Along the side, I would do a 4x minus 3. Again, I apologize for my handwriting. It's really hard on a Mac, and with all I'm doing is the keyboard. And then go ahead and multiply basically all these pieces by 4x, multiply all these pieces then by -3, and your diagonal should create your like terms that you're going to combine. Remember, we add exponents. So like this box would be 4x to the 3rd power. Now, I'm just going to go ahead to kind of the next part without, again, showing the whole box method just for time's sake for this video. But I suggest that you pause the video and try it out on your own. I really encourage you to do that. So what I did is I'm still multiplying. I know this is a lot. Every piece, I'm distributing every piece to the 4x and every piece again to the -3. So x squared times 4x gets me 4x to the 3rd. -8 times 4x gets me -32x squared right here. I was like, that's not in the right spot. 4 times 4x is that 16x. And then I went back and did -3. So that's where I get my -3x. -8 times -3 is a positive 24x. And 4 times -3 is a -12. Watch your negative signs because that's the biggest mistake students make, I would say. From here, you're just combining any like terms. So like terms that I see would be these pieces with the x squared. And then these pieces with the x. So from there, 4x to the 3rd comes down. This would be a -35x squared. This would be a 40x, and then you would have your -12. No domain restriction because you don't have anything in the denominator of a fraction. All right, going on to page 2. Remember, write any questions, write any notes, pause the video, rewind, try some stuff on your own as we move along. Okay, this is the same process. However, as you notice, instead of an X here, we have a number, okay? So I like these better personally because your answer is gonna just be a number instead of having all of this junk with the variables and stuff. What you basically have to do is evaluate F at that number and G at that number and then do the operation that's happening in between, okay? We kind of did this yesterday. So F at -2 and then G at -2. All right, so F at -2, literally just like yesterday, I'm going to do F at -2, and then I'm gonna put -2 everywhere that I see an X, and then I'm gonna evaluate. So again, I encourage you to pause the video and try this right now and see if you get what I get in a moment. No, really, go pause the video, I'm waiting. All right, hopefully you actually did that for me. Again, it's only gonna benefit you guys, okay? So square this first and you get 4. 4 times 2 is 8. Then this would become a +2 because minus a negative becomes a plus, and then you'd have -12. So 8 plus 2 minus 12. Do that in the calculator, you get -2. Then you need to do G at -2. So I set that up. The only spot that I have an X is right here. So -2 plus 7, pretty easy for that one, it's a 5. And then you're doing the math. The math says to add the 2 together. So you're gonna do -2 plus 5. This goes first because it's in the first spot. So make sure you do F first. -2 plus 5 is a 3. And that's what this whole part's about. So I encourage you guys to pause the video, try 8, 9, and 10. This one, you're gonna do it again. F at 8, G of 8, subtract. F at -1, G at -1, multiply. F at 5, G at 5, division. Make sure you restrict the domain if you need to. So really go pause the video and try these guys, okay? All right, so hopefully you did this. F at 8, So 8 goes in all the x spots. I would square this first, get 64, and 64 times 2 is 128, minus 8 minus 12. Do that math, 108. G at 8, 8 plus 7, 15. Subtract in order, 108 minus 15, 93. Again, if I'm going too quickly, pause, but really pause, try it on your own. All right, move my little face up here now. All right, f at -1. So -1 squared and minus -1. -1 squared is 1 times 2 is 2. Minus -1 would change that to a plus sign, minus 12. 2 plus 1 minus 12. -9. And then g at -1, -1 plus 7, you get a 6. So -9 plus 6, times multiplication. It's really late. Sorry guys, I'm tired. -9 times 6, and you would get a -54. All right, next one, f at 5 divided by g at 5. So you would do f at 5. 5 squared is 25, times 2 is 50, minus 5, minus 12. You get 33. And then g at 5, 5 plus 7, you get 12. Then you have to divide, so you would do 33 divided by 12. There's no domain restriction because there's no x in the bottom. Okay, so you've seen without a number. That's what we did here. We were combining functions. Without numbers, just expressions. You've seen with a number. Last little bit is composition of functions. So another method to combine functions is called composition. Given f and g, the composition function, this is read f of g of x, is defined as such. It kind of looks like it says fog, but it's f of g of x, and you put f and then parentheses g parentheses x. I know that looks crazy, but if you want to remind yourself of this, you're putting g of x inside f of x. So you're putting the g part inside of the f. Remember that you can have different letters here, so just go based off of these letters, but the second part is always going inside the first letter. Okay, so I'm going to try to hopefully make this simple for you. G is going inside f. One thing I like to do is actually write that out, write f parentheses and then whatever the piece is that's going inside of it. So I actually write out f parentheses x minus 1. And the reason that I do that is it tells me everywhere I see x, I'm going to put x minus 1. Okay, so I'm putting the g inside of f. That's x minus 1 inside of f. And everywhere I see an x in the f part, I'm putting x minus 1. These are probably the most tricky for students. So there's only x right here being cubed, so really it's going to become x minus 1 cubed. And then plus 8 because that's part of the f function. Now what this means is you're going to do x minus 1 times x minus 1 times x minus 1. And then plus 8 at the end. And I know that's really confusing, but essentially it's a 2 by 2 box and then it becomes a 2 by 3 box. So you could box method over here or on a piece of paper or foil. Again, for time purposes of this video, I'm going to just move to the answers, but you could pause right now and try to box and box to practice. We will practice again more in later units as well. So if you multiply all this out, you end up with these two I did first. So you could see, okay, I multiplied those two. X squared minus 2x plus 1. That's from foiling and simplifying at the same time. Or you could box method. Then I would have my 3 by 2 box. This gets multiplied to everything over here. And I end up, and I have to tack on that plus 8 at the end, okay? So you end up with an x cubed minus x squared minus 2x squared plus 2x plus x minus 1 plus 8, okay? I know that's a lot, I'm so sorry. And then combine like terms. X cubed is my only x cubed. Negative x minus 2x gets me negative 3x squared. Plus 2x plus x gets me plus 3x. And then negative 1 plus 8 gets me plus 7. Okay? All right. number 12, h of g of x. So g of x is going to go inside h, okay? It's always the second part going inside the first part. So again, I write h parentheses x minus 1. That means everywhere I see an x in h, I'm going to put a whole x minus 1 there. So this looks like 5, instead of x, it's x minus 1, minus 3. So then what you need to do is distribute. So you're going to do 5 times x, 5x, 5 times negative 1, negative 5, and bring a negative 3 down. So 5x minus 5 minus 3. Combine like terms, which is just right here. 5x minus 8. That one was a lot simpler than 11. 13 is going to be very similar to 11. It's going to be crazy again because you are putting h inside f this time. So h is going inside f. So in this little x part, you're putting a whole 5x minus 3. So 5x minus 3 cubed plus 8. This is going to be a very long one and big numbered. So you're going to write 5x minus 3 times itself 3 times, and then you have plus 8. Because that's what cubing means, guys. It doesn't just mean I'm going to distribute that 3 to stuff. I'm going to write it out 3 times and multiply it out 3 times. So again, I think I did it twice and then I did it the third time. Yeah. So I just multiplied 2 first. I got 25x squared minus 30x plus 9. You got to do it one more time and add 8. So again, you can pause the video and try this 3 by 2 box. And I added the 8. I just did it all in one swoop. So 125x cubed minus 225x squared plus 135x minus 19. Sorry. I know it's a doozy. All right, g of f of x. So inside g is going to be the f of x part. So I'm going to write g with the x to the third plus 8. So everywhere you see x in g, you're going to write x to the third plus 8. So instead of an x, we have an x to the third plus 8, and then there is a minus 1 there. Again, this is replacing a single x here. And then you're just saying x to the third plus 7 because you're combining 8 minus 1. All right, last little bit is putting a number instead of x. This actually makes it a lot simpler because, again, you're ending up, oh, look at me giving you answers. You actually end up with a number instead of letters. I know all of you are getting the answer, but that's not going to help you. So, all right. So what I want you to think is like inside out. So h gets the 2, and then g gets whatever this evaluates to. So it actually ends up looking like this. Okay, g of h of 2 instead of g of h of x. So h of 2, evaluate that, then whatever that is, evaluate it at g. Okay, so first just do h of 2, inside out. So h of 2 is 5, and it says use the same one, so I'm using this one, 5x. So 5 times 2 minus 3, which is 10 minus 3, which is 7. And then you're going to do g of that, g of 7. So in the g function, you put 7. So 7 minus 1, because in the g function, it's just x minus 1. So 7 minus 1 is 6. So your answer is 6. Your final answer is 6. A little bit easier when there's numbers. Same thing here, h of f of negative 6. So do f of negative 6 first, then h of whatever you get. So h of f of negative 6, inside out. So f of negative 6, you're doing negative 6 to the third power, some parentheses around there, plug it in your calculator, and then plus 8. So you get negative 208. So negative 6 to the third power plus 8, negative 208. And then you do h of negative 208, so come back up to h. That means 5 times negative 208 minus 3, which gets you a final answer of negative 1,043. Okay, I know this is a hard lesson without me there, so we will do some practice together when I come back, and ask me any questions that you have, okay?